So let's start up. I'm going to share my screen. Let's like move this over here to here and there to there. And we can go over the homework. And also, obviously, if people have questions, we can discuss that as well. Let me just bring that up here in my second screen. I say, how do we ever get along without second screens? I do not know. Okay, so what I had, oh, I know, I can just like copy this now, right? Yes, oh, yeah. I see you raise your hand, just like, go ahead, you can put it in the chat. Although I guess I have to open the chat. Where did I put it? Multiple screens, oh, there we go, here we go. If you have a question, you just like pop it in the chat there. I'm always happy to answer questions. Let's see if I can like get this all to work. Oh, I know what I want to do. I wanted to turn this into Markdown, right? Yeah, there we go. That's like kind of ugly looking. Oh, I see, because it was indented. All right, and then here, we're gonna also make this into Markdown. I'm so getting to this Markdown thing here, because then it looks like that, that looks like that. Whoa, fancy, fancy. Hey, Ellie, nice to see you. Okay, so let's go over these homework questions that I put into the chat last week. So write a program that asks the user to enter sentences one at a time and stop asking when the user enters an empty string. And write each word that the user entered on a separate line of a file, followed by a space and the number of vowels that the user wrote. So there are multiple parts to this program, right? And as programs get more complex, there are more sort of moving parts to keep track of. And so trying to prioritize, what are we going to do, followed by what, followed by what, followed by what, that becomes really important. I'll just give you an example from like real life. I'm involved, you'll see in like another 2 weeks or so, a bunch of us in the Python training world are going to be doing this like joint fundraising sale whole thing. And so in order to get that to work, I actually needed to like basically at breakneck speed get a whole bunch of programming things working together. So yesterday, in between teaching and after teaching and staying up late, I was getting it all together. And at first I was like, oh my God, this is overwhelming. How am I going to do this? I've never done half these things before. But you sort of set, okay, what's my first goal? Then my second goal, then my third goal. And little by little, you get through it. So in order to do this, we're going to have to ask the user to enter sentences. But we're not looking at each sentence. We're looking at each word in each sentence. And we want to write that to a file on disk. So what I'm going to do is I'm going to start off this whole thing by opening a file for writing. So I'm going to say here with open, and let's say here, we'll call this like, vowel counts.txt for writing as F. I'm going to call this out file. I like to use that. And now we know that when the with ends, that the file is going to be flushed and closed. So I don't need to worry about that. Well, now what? Now I'm going to ask the user to enter a bunch of words. How many words? I don't know. I'm sorry, sentences. How many sentences? I don't know in advance. So I can now say, while true. Okay, well, now what? And by the way, you could have done the opposite way around. You could have had the while true with the with inside of it. I'm going to do it this way. I don't know really why, but I am. Then what? Well, we're going to get a sentence from the user. S equals input, enter a sentence. And we'll strip that. And then we can say if S equals empty string, break. We're going to break out of the while loop. What happens when we break out of the while loop? Well, we go directly out of the with. And then that means the file is flushed and closed. Okay. But if we did not get an empty string, then what we want to do is go through each word that the user gave us. How do we break a sentence into words? We use split. Split takes a string and returns a list of strings. So what I can do is I can say here for one word in s.split. And now I'm running a loop, a for loop over each word, one by one by one. Well, what do I want to do with this word? I want to find out how many vowels it has. So what I can do is I can say here total equals 0. And then I can say here for one letter in one word. And if you're thinking, oh my God, this is a lot of loops inside of loops. Yes, it is. That's the way these things work. And so by breaking it down piece by piece, you can sort of say, okay, I'm in this outer loop, I'm in the inner loop. But each piece at a time, it's what we would do as humans, right? We just don't think about breaking problems down this much. And here we have to be really explicit. And now for one letter in a word, what I can say is if one letter in ARU, we can even make it capital if you want, fine. Then I'll say total plus equal 1. And then finally what I can do is when I am done going through each of these letters, I can say here, out file write, and we use an F string. And what do we want to write? We wanted to write the word, space, number of vowels. So I'll say here, one word, space, total, and then I'm going to have a new line. And look at what happens here. So I'm going to run this here. I'm going to say this is a test. This is a very important test. A test should have no encyclopedias attached. Enter. And now that I'm done with that, we can go take a look. Oops, did I just erase that or something? No, I just hit it. Okay. So now what I want to do is I'm going to use the Unix cat command to look at valcounts.txt. And look at that. Each one of our words is there on a line by itself with the count of vowels. Not too shabby, I'd like to think. And so this is what programming is all about. It's taking a big problem and breaking into many smaller problems and attacking the first one, the second one, the third one. And there's a sort of philosophy of programming known as agile, which has gotten a terrible, terrible reputation over the last decade or so, in part because it is taught terribly and it's become a huge buzzword in companies. But the original idea of agile software development, among many other things, is do the smallest thing possible that will advance you toward your goal. So I'm going to do a little bit of programming. Oh, I'm a little closer. Good. Then a little bit more, then a little bit more. And each step of the way, you're going to get a little bit closer, knowing that what you're doing is not right, but it's closer. So what you could imagine is just writing the word and one at first, if you don't really know how to do the totals here. And then, okay, we're going to deal with the totals, and so on and so forth. So Ronnie asked, did it just complicate things when I use the dictionary? First of all, I love dictionaries. So how can I say dictionaries are bad? I would say in some ways, right? I would say there's both good news. So let me show an example of what Ronnie's talking about, because I think this different style here of doing it, several people did that in the forum. I think I responded to everyone, but I have a feeling I did not. Some people did it in a dictionary. So how did they do that? They were like, let's do counts here equals empty dictionary. And then what I'm going to do is I'm going to have my whole while loop. So I'm just going to copy this whole thing here, just about. Copy, where I can actually move that back. So I'm going to do a shift tab to move it back. Right, so we're going to do all this, but at the end of the day, we're not going to write to the file just yet. Instead, what we're going to do is say counts of one word equals total. And so as we go through each word in each sentence, we're just adding to the dictionary. And then we have a dictionary full of words and counts. And then what you can do is you can say with open, let's say, dict counts.txt as out file. So we're opening the file here. And then I can say for key value in counts items, we say out file write. And it's going to be the same thing as before, right? F string of one word space total \n. And so this will give us exactly the same result. So what's the advantage of this one? The advantage is that you're first collecting the data, and then you're printing the data to the file. And I actually really like doing this. So why did I not demonstrate it? Because there's a tiny, tiny issue with this. And that is, if you get too much data, the size of this dictionary is just going to explode. That let's say someone decides to be extremely wordy, like me, and basically they end up giving you tons of millions of sentences. Well, millions of sentences, it's going to use a lot of memory because the dictionary still has to hold on to all of those words. Whereas here, we're just going to write one word at a time, one word at a time, one word at a time. We don't need to use any memory for storage. The other small issue is that a dictionary will only have each key once. Like each key is unique. And so if a word repeats itself, like let's say if I run this here. So I'm going to say here, this is a test. And hello, this, test. So watch what happens here when we look at this, cat dict counts.txt. Whoa, oh, that I did wrong. Oh, because I did one word in total. Okay, let's try this again. Key and value. Hopefully someone noticed that. All right, this, test, right, and this. Also, test. And now if we look at the file, there we go. This test and also. What happened to all the subsequent times that we had each word? Well, basically, it was just like put into the dictionary, but it didn't really change anything. All right. Other questions about any of this? Okay. So let's go on to the next exercise. which was, let's pretend we're creating a sales report for our company. As if companies are selling anything nowadays. Never mind. Repeatedly ask the user to enter a product name and a number of units sold. So we're going to say product amount, product amount, product amount. All right, and they should be separated by white space. And we're going to talk about this in a moment as well. When the user enters a blank line, stop asking and write this into a CSV-like file, meaning that it's going to have product name, comma, amount. So we're basically translating formats here. We're getting it from like white space separated into comma separated. And this happens all the time, this sort of translation of formats. So how are we going to do this? Well, once again, there are a few different ways we can do it, but I'm going to stick with like my model from before. I'm going to say with open, we'll say here sales report.csv as out file. And now I'm once again going to ask the user to enter things again and again, while true. Well, let's get it. Let's say S equals input, enter, product, and what did I say here? Quantity, yeah, number. Then we can say here, if S equals empty string, break. By the way, if you see these things repeating themselves a lot, it's because they repeat themselves a lot. This is a normal thing that happens. Like programming just uses, it's sort of like when you talk to people, use the same phrases again and again, the same idioms, same is true in programming. So now what am I going to do? Well, I have this, so I want to write it to the file. Well, I already have the file here, but I have to break it apart. So I'm going to say here, I want to break it apart. How can I do that? We can use split again, s.split. What are we going to get back? A list of strings. And right now, I'm going to assume that's product number separated by white space. So I can just say here, product number equals s.split. This is using unpacking. And unpacking means that on the right, I'm going to get two elements. And so on the left, I can assign it to two different variables. And then I can just say here, out file, right of an f string. And we're going to say here, product, comma, number, new line. So if I say here, you know, books, space 10, and coffee, space 20, and I don't know, tea, space 25, and computers, 2. This is a very eclectic sort of store, I guess, right? And I don't know, what else do I have on my desk here? Right, a lamp, we've got, we sold 4 of those things. I press enter, and if I now look at salesreport.csv, sure enough, I have those, in name, value, name, value, name, value, and just to show off again, salesreport.csv. This is a Macintosh, this is a Unix and Macintosh thing. The Mac thing is you can use the open command to open a file, and voila, in Excel, perfect for our management and sales friends. But there is a little bit of an Achilles heel here. And that is, and several of you pointed to this in the forum, what happens if the product contains a space character? Oh, bad news then. So I'm going to say here, we sold, you know, books 10, and I sold ice cream 20. Ba-boom! Blows up on us. Why? Too many values to unpack. Meaning, when we did a split on white space here, we said, take every white space and break it, and that's going to give us back, well, in this case, it gave us back a list. In fact, if I look here, what's S? It's ice cream 20. So I say s.split, we're going to get that. And we can't assign these 3 elements to 2 arguments, to 2 variables. So what can we do about this? There are actually a few different solutions. The easiest solution, I think the best one to use right now for our purposes, is to say 1. Actually, we'll have to say none, comma 1. Huh? Well, it turns out that functions can have default arguments. And so until now, we've been using the defaults. And so what I'm going to say here is split on white space, that's none, and max of 1 time. And what do you know if I say here split of none? Oh, actually, I could just say like max splits. Yeah, oh no, it won't let me do that. Fine. Oh, none, sorry. Look at that. Now we have ice and cream 20. Oh, sort of what I wanted, but not exactly. So this is where it gets really tricky. We can use rsplit. What does rsplit do? It splits it from the right. And now if I say books 10, we're doing great. And ice cream 20, also doing great. And I press enter here. And now if we look in the sales report file, what are we going to find? Oh, books, ice cream. You see, it actually did the right thing. And if I look at it, let's just look at this here. cat sales report.csv. Sure enough, we see that it did the right thing. Now, none of you use this in the forum, and that is okay. You aren't expected to like start thinking, well, what if strip takes an optional argument? And what if there's a version of it for right side, like called rstrip? I would not have expected that of you. So what a whole bunch of people did, a whole bunch of people, I think there were like 3 or 4 people, very clever, they said, well, let's be sort of on the safe side here. So what I can do is I can say, final, space index, or let's do set index equals sr find of space. And that's going to tell us where is the rightmost space character. And then what I can do is I can say here product equals s until sep space. And then the number equals s from sep space plus 1 until the end. And then I think this will actually work. So I can say like, books 10. Oh, it didn't like that. What did not like it? Oh, because I said sep index. Ah. Here's a little trick. You got to use the right variable name. Okay, books 10. All right, and ice cream 20. Enter. And now if we look at sales report.csv, look at that, it worked just fine. There are always multiple ways to solve any problem. The question is sort of how do you decide to do it? There are some other options that we could use, but I don't want to like confuse things too much. By the way, this shows how much you need to worry about user input and all the crazy things they can do. So like this thing that I was working on yesterday until late at night, it's dealing with coupon codes. So I wanted to make sure I'm like generating, basically the people I'm doing this giveaway sale with in a few weeks, it's supposed to be a secret, is like basically we're supposed to generate coupon codes. How many coupon codes? Oh, like 250,000 coupon codes. So fine, that's like the easy part. But then I wanted to make sure that when someone came to redeem the coupon, that they were actually using that they were using a coupon that was valid. So I had to check it. Oh, but wait, what if they're using uppercase and lowercase and all sorts of other crazy stuff? Larry asks, I prompted for a comma input and split on comma. Does that work? Absolutely. Absolutely. If you say to people, don't enter product space number, rather do product comma number, yeah, that solves a lot of problems. Absolutely, positively. Right. And so a lot of times when you get stuff, when a computer asks you for input, it will often be doing it in a way that's good for the computer rather than good for you. And that's sort of, that's just one of these things where how easy does the program want to make it for themselves? The worst thing you could ever ask of a user is just like, oh, enter some text, right? Because then what can you do with entering that text? It's not that easy. You want to make it as structured as possible. And if you can, not even let them say enter one thing, comma, another thing, have them enter them separately. That's definitely better. More annoying for the user, but definitely better. Other questions about any of this before we move on to our subject of the day? Okay, so let's talk about functions. And so we've been using functions. We've been using lots of functions. We've been using input, we've been using open, we've been using a whole bunch of functions. I would even call, for our purposes here, methods, sort of like close cousins of functions. So what are functions? Functions are basically the verbs of a programming language. They get stuff done. And so it's very nice that I have all these built-in functions that I can use. That's great. But here's the thing, I can write my own functions. I can create new functions, create new verbs in the language. And in that way, every program that you write is creating a specific vocabulary to solve certain kinds of problems. What do you call your functions? That's up to you, just as what you call your variables is up to you. And you want to use variable names that describe the function, or I should use the word function, that describe the use case for that data in the same way. Oh, let me silence my phone. Sorry about that. In the same way, come on. Silence phone. There we go. All right. In the same way that you can have data that represents what you're working with, you can have functions that represent what you're working with, and their names can be really useful and important, right? You don't have to, like the function input didn't have to be called input. It could be called hippopotamus, but then you wouldn't remember it. It wouldn't have as much semantic meaning. Do we need functions to get things done in our program? No. We don't need to write functions to get things done. But boy, oh boy, it would be really bad if we didn't. Why? What do functions give us? Functions allow us to give a name to a set of activities. And it's sort of like, so, you know, if someone asks me, what did you have for breakfast this morning? And I say, I had an omelet for breakfast. Right? Just by saying I had an omelet, I'm using a verb. I made an omelet, I ate an omelet, how should I describe it? That automatically conjures up in your head a whole bunch of different steps. I opened the refrigerator, I took the eggs out of the refrigerator, I put a pan on the stove, I put the oil in the stove, like a whole long list of things that I don't need to say at length because I can just say, I made an omelet. And in the same way in our programs, instead of having this long list of commands again and again and again, I can then just say it once, keep it short, keep it snappy, keep it simple, keep it readable and understandable. And one word can represent a long list of different actions. So by having functions, we are shortening our code. We're giving our code additional semantic power, and we're then making it possible to build things on top of it. So if I say, I made a fancy breakfast with, I don't know, omelets and fresh squeezed orange juice and toast, right? All of those phrases, all of those terms that I've used, each of them can be broken down into additional steps. But by saying it in a short form, you understand what I'm talking about, and we can communicate more effectively. There's also the point of the whole dry rule. Don't repeat yourself. You don't want to have the same code here and here and here and here in your program, because what's going to happen? You're going to need to modify it. And if you have to modify in one place and you've copied it, you have to modify it in many different places. So writing functions gives us incredible power and is a huge a part of what we do in programming. By the way, so like, again, to go back to this thing that I was writing yesterday, to deal with like coupon codes and registration and courses and so forth. So what I was doing was I had to write a function. What kind of function? A function that someone enters information into a website, sends information to that website. What is going to execute on the website? A function. When you go to a website, what does that mean? It means that something on the other end is executing a function, something that has to happen again and again and again. Functions are our verbs. And so far, we've been dealing mostly with nouns. Time has come for us to create our own verbs. So here I'm going to create one. I'm going to use the word def, right? So def defines a new function. So def, and I'm going to say hello. Now, why do I have these empty parentheses here? The empty parentheses mean this function takes no arguments. It's always going to do the same thing. We're going to see how you can change that. But between the parentheses, we can put a bunch of different variables, and we'll see that in a bit as well. So right now I'm saying we're defining hello to be a function that takes no arguments, colon, and then what? Well, what else are we going to do in a function called hello? We're going to print, well, just print hello. End of definition. I've now taught the computer a new verb. And unlike children, they will remember it, right? So you teach a child a new word and they're like, I have no idea what you're talking about. Teach the computer, it'll remember it for good or for bad. How do I now execute this function? With parentheses, just like we've done with every other function. I execute len with parentheses, len parentheses something. Input parentheses something. Parentheses are the way that we say in Python, go execute the function. So I say hello parentheses, and what does it do? It prints hello. Whoa, amazing, right? So we can create as many functions as we want with whatever names that we want, doing whatever we want, and they're all going to include in them a bunch of different functions, basically. We're going to assign to them, we're going to change them, we're going to check things. All the code that we could do otherwise, separately, we can put in a function. But you know, this function is kind of boring. I mean, friendly, but boring. And that's because really every time we run it, it's going to do the same thing. So I'm going to redefine the function. So redefine the function by using def and the same function name again. And the previous version will no longer be available. Now, this is an important point because there are many programming languages in which you can actually define a function multiple times. And the language then figures out which of those times it should be using based on the number of arguments and types of arguments. Not so in Python. When I define a function, it gets rid of all the previous versions. So I'm going to do def hello, but now I'm going to add in a twist. I'm going to say hello name. And notice here, so name is a parameter, right? A local variable, or like a variable that gets its value from the caller. So whoever calls this function, whoever invokes this function, will have to provide name. And then I can say print hello name. Oh, helps put in the curly braces. So now if I call hello and say hello world, whoa, and I can say here hello Ruben. I can call this function as many times as I want with as many different arguments as I want. And we can say here that the value we pass to the function is an argument. Now, most programmers, if like forced to try, would never be able to tell you the difference between a parameter, which is the variable, and an argument, which is the value. You will hear programmers constantly talking about arguments and parameters and mixing them up. I thus give you permission as well to mix that up. Don't tell the programming language syntax police, but everyone does it. So we have indeed now written a function that if we want to be friendly, we can be friendly to whoever we want. Right? I can do this. I can put this inside of a loop. I can put this inside of an if. I can put this however I want. All sorts of possibilities now to define this. Okay, any questions until here? Okay. Oh, and by the way, I just realized I never set up the GitHub auto push. So I'm just going to do that now. Give me a few seconds, please, while I do that. And then anyone who wants to follow along will be able to do that as well. There we go. And so if you go to, I'll put this in the chat as well. There we go. Okay. Now, here's a question for you. What happens if I now just say hello and I, no arguments? What's going to happen? I get an error. I get an error. Python says to me, no can do. Python says to me, this function requires that you pass it an argument. And I even know the name of that argument. That argument is, ironically, called name. So basically, Python is saying, if you don't give an argument, I don't know how to run this function. It's not possible. Now, you might say, wait a second, I defined hello without an argument. Yeah, but afterwards, you defined hello with an argument. And remember, when you redefine a function, when you define a second time, the subsequent times take priority. And the previous version of the function is gone, goes away. So we can then write a function that takes this and everything. But there's still a little bit of a difference between the functions that we've run so far in this function. Let me give you an example. This is a hard concept to understand. So if I say x equals len of ABCD, what's going on here? Well, we're running the len function on ABCD. It's going to return the number 4. And it returns that number. It gives us back this value. And we then put this value into x. So x, of course, is going to be equal to 4. So far, so good. What if I say x equals hello world? Well, it prints on the screen, and what is the value of x? Hey, what's the value of x? None. There's a value of none. Well, that doesn't make sense, right? Len returned 4. So shouldn't hello return our string hello world? And again, I'm warning you, there's a bit of a subtle point here, but it's a really important one. When I call a function, I want to get a value back from the function. And you can think of it like a mathematical function. When I say, f of x equals x squared, I want to get back a value. But our function is not supplying a value. Our function is printing something on the screen. Printing something on the screen is an action. It's something that's being done. It's not returning a value to the user. And so we can print as much as we want or as little as we want our function. But you can only return one thing from a function. And that thing that we return is what would be assigned to a variable. So I don't want to print in a function, typically, unless it's for debugging, right? And this is a big rule of thumb that I try to tell people. Don't print from your functions. Rather, return values from your functions, right? And big caveat here, except for debugging and when the function is meant to print things on the screen. So if I change this function now, I don't want it to print. Instead, I'm going to use the special Python word return. And return means don't print it on the screen. Give whoever called this function the value back. Oh, I see this in the Q&A. Let me just take a look. Can a function argument be another function? Ah, ha, 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 ha. Just wait a few moments, and then you're going to fall off your chair. So sit down. So if I now say def hello name, return hello name. Now if I say hello world, look what I get back. I get back here a string, and this is subtly different from what we saw before. Before it was printing hello world on the screen. Now it's returning the value back. What's the difference? Well, the difference if I say x equals hello world, we see nothing. Why do we see nothing? Because the returned value, the value that the function gave back to us, was stored in x. And if I now say, hey, what's x? It'll say hello world. So my point is functions should return values. What kind of value can you return in Python? Absolutely, positively anything. You can return a string, you can return an integer, you can return a tuple, you can return a dictionary, you can return anything you want. You can return absolutely any type of object. By the way, if you return a tuple or a list, that basically means you get to return more than one thing. It has to be together, but more than one thing for sure. So we always want to return from functions because that gives us flexibility. I can say print hello world. And then what am I doing? I'm calling hello world. That is going to return a string. And then I can pass that to the print function. And then it'll print it out on the screen very nicely. I'll give you the analogy that I've come up with, which is not great, but it's better than anything else I've come up with, which is if you go to a store and you buy something, the store vendor, the person, the cashier there will give you the thing that you bought, hopefully, presumably, right? And that is the return value. That's what you got back. But there's also perhaps printing going on, like printing inside the cash register to keep track of what you bought. So it's like two different directions, two different things. What a function prints and what a function returns. Now, Chad asked a question, which is, can a function be an argument to another function? I'm going to get to that in just a moment. But before that, what if I say here, hello of 5, right? Can I pass an integer to this function as an argument? And the answer is yes. What if I say hello of 10, 20, 30? How about a list? Yes. What about a dictionary? Yes. And finally, what if I say hello, hello? Yes. And this is something that scares the pants off of people from languages like C# and Java and so forth. The notion that our function here can take absolutely, positively any type of value as an argument. Now, does that mean that every function is going to work with every kind of argument? Obviously not. Let me give you an example. If I say here, def add of A and B, notice now 2 parameters, and return A plus B, a totally useless function. So I can say add of 3 and 5, fantastic. Add of 10 and 8, fantastic. Add of A and B, fantastic. Add of A and 1, not so fantastic. So basically, Python will allow you to pass in any type of value for any parameter, any argument for any parameter. There is no way in the language to say this variable name, this parameter name should only get a string. That simply does not exist in the language. And people who come from these sorts of languages, what are known as dynamic languages, think this is just the greatest thing ever because it gives incredible flexibility. I can write the same function that will work with many different types of data. People who come from what are known as static languages, statically compiled languages, think this is craziness. They're like, wait a second, you can accidentally call a function with the wrong kind of value, and no one's going to complain. It's just going to blow up when you run it. To which the dynamic programming people said for years, yeah, but if you're a good programmer, that won't happen. And this made the statically compiled language people sputter and get angry even more, which was, of course, the point of what the dynamic language people were saying. But it turns out they do have a point, that when Python is used, or dynamic languages in general in this sort of family of programming languages are used in very small projects by small numbers of people, they tend to be very good and they tend to communicate a lot. And these sorts of problems don't happen that much. But now that Python's being used in projects with hundreds of developers, thousands of developers, there's starting to be a little bit of pushback on this. And so over the last few years, people have actually introduced what's known as MyPy, which is not exactly type checking in Python, but it's closer to it. And it's something that it looks like the Python community is moving in the direction of. I don't want to get bogged down in that, but I do want you to understand that this is a known problem and one that people are trying to solve. It's very smart, impressive people are working on solving it as well. If any of you use Dropbox, so Dropbox uses a lot of Python, and they actually sponsor the work on MyPy and similar sorts of type checking to make their code as well as everyone else's code better. So long answer to the short question is you can indeed pass whatever you want. And because functions are objects in Python, functions are just another kind of data with the added benefit that we can execute them. Yeah, you can pass functions as arguments to other functions. I'll even give you an example of that. If I say here, hey, help on len, what does this len function do anyway? Help, look at this, help is a function, and what's it getting as an argument? Len. And if I do help on stir.upper, we will get the documentation for stir.upper. Returns a copy of the string, convert to uppercase. Fantastic. If I say help on hello, nothing. No help. Well, why not? Well, who's going to write it if not us, yeah? So how do we document our function? We are going to document our function with a doc string. Use a doc string to describe how your function should be used. And that is a string immediately after the def line in a function. So here's our original function, right? Hello name. I am now going to add a doc string to it. I'm going to go right below the def, and I'm going to say here, this is the best function ever written. It's so great, it gets a 2-line doc string. I now define my function. Notice, this string here is not assigned anywhere. It's not really going to be used by the function during the function's execution. Rather, it's just there because Python knows to look for it. And now, after I've executed this, if I now say, hey, give me help on hello, look what we get. The doc string is printed right after it. Now, this is obviously a nonsensical doc string. But before I show you how to write good ones, a very important point, right? So comments are meant, right, things that start with hash marks, are meant for the people who will modify and maintain the program, right? But docstring is meant for people who will use, or I should say, use the function, right? Use the function. You can think of comments as sort of like the manual that your mechanic uses to fix your car. And the doc strings are sort of like the manual that you use or that you got to know how to drive your car, right? So this is like the owner's manual. And this is more like the maintainer's manual. So don't think that if you have lots of comments, you don't need a doc string or vice versa. They serve two different audiences and two different purposes. So, all right, what would a good doc string be like? Well, here I go back all the way, to when dinosaurs roamed the earth, and I took the course in software engineering back in university. And our professor of software engineering made it very clear that what we would call an API documentation, right? Something that documents that describes how things work. We should say three things. We should say, what does it expect or requires? Or we could say requires. And what does it modify? What does it modify? And what does it returns? If you can describe all three of these for a function, then people will understand what your function does. It's nice to give it a little title there. Oh, and Mal in Seattle asks, can a doc string be wrapped with single quotes or double quotes? The answer is all kinds of quotes. As long as it's a string, it is traditional to use double quotes and triple quoted strings. However, you can use single quotes for triple quoted strings, and you can use a regular old string if it's just on one line. However, it's traditional in doc strings to use triple quoted strings for reasons that are not quite clear to me. I mean, I understand why it's multiple lines. So I can say here, right, a very friendly function that returns a greeting. So what is it going to require? Expects, takes one argument, presumably a string. Modifies nothing, returns a string with a pleasant greeting for people of all ages. And now if I say, hey, what's the help on hello? I will see what it does, and it's easy for me to understand what I should do. Okay. Other questions? Oh, can the triple quote? Oh, so triple. So let me. Okay. So Mal asks, can the triple quotes be single quotes or double quotes? So triple quoted strings can be 1, 2, 3, 1, 2, 3, or 1, 2, 3, 1, 2, 3. Either is okay. However, they're traditionally done with double quotes. But you can like, all right, excellent, sure. Just like clickety-click here to get rid of those questions. Okay. Other questions about this from anyone? Okay. So let's say, how could we write a more sophisticated function? For example, let's say I want to, Python comes with a built-in sum function that takes a list. I can say here, sum of 10, 20, 30. And sure enough, I'll get 60 back, right? Can we write our own version of sum, right? And note, do not call it sum. Python will let you do that, and it's a big problem. So how can I do that? Well, I'm going to say here, I'm going to call it my sum. And it's going to take a list of numbers. Guess what I'm going to call that parameter? Numbers. Oh, I'm so creative. And now what? Well, what are we going to do? We're going to assume we have a list of numbers. In fact, I'm going to write a docstring here, right? So returns the sum of a list of numbers. So it requires, right, a list of numbers as the parameter. So Dory asks, you can overwrite the original Python functions. And the answer is, as always with me, yes and no. You can, but that's rare. What you can do, though, and what is very common, is for people to call their functions the same things as built-in functions. And then you're not getting rid of the built-in functions, but you're sort of masking them or shadowing them, that your functions will get priority. This is a big, big problem in Python. I constantly see people calling dictionaries dict and integers int, and let's say, and then defining a function called sum. And then later on, they get into trouble. Now, I actually filed a bug report. I might have mentioned this. I filed a bug report with a Python core developer saying, I think there's a problem that should come out with a warning. And they said, no, this is really useful sometimes. To which I say, no, it's not, but fine. All right, requires those numbers as the, as the argument, let's say, passed as an argument. Modifies nothing, and then returns, and we'll say an integer or a number with the sum of the argument's elements. And sometimes it's hard to think about how to document these things, but it actually can help in crystallizing our thoughts. So now what? What do I want to do? I know that numbers is going to be a list. How can I take all the numbers in that list and sum them? Well, I could call the built-in sum function, right? But we're not going to do that. So I can say here, total equals 0 for one number in numbers, total plus equal one number. So I'm going to go through each of the numbers in this list, assigned to one number. I'm going to add it to the total. And then I'm going to say here, return total. What happens now? So I say my sum of 10, 20, 30. Look at that. We defined a function. Now, it's not the most sophisticated function in the world, but it is a function and it works. And all functions look this way. Def, name of the function, however many parameters you're defining, colon, and then the body of the function. In the body of the function, you can have assignment, you can have for loops, you can have if statements. You can even have return more than once, but only the first one that's encountered is going to actually do anything. So you can say, if this, return that. But if that, return another thing. Oh, can you set default values for function parameters, Mike asks. Also, can you have optional parameters? So the answer to both questions is not only yes, but that both of those are done in exactly the same way. So how do we do that? Let's do this. I'm going to say here, oh wait, done. So I'm going to say here, def add of A and B. return A plus B. So now I have to provide two numbers, add of 10 and 3, or two anythings that we can add together. But what if I'm lazy and I just want to say def, add of 10, and can't the function assume that I want to add 2 to this? Well, no, Python does not work that way. It says you're missing one required positional argument B. But I can say this. I can say def add of A, comma, B equals 2. And now what this means is B is now an optional parameter. If missing, we'll get, it gets value 2. So I can now say add of 3 and 5. Works just fine. I can also say add of 3, and it adds 2. And this is where things start to get really interesting. Now, remember before, just before earlier today, I was showing you how we can say here, like if I say A space D, E, and I said split, and I said we can say none, or we could just do split like that. I can also say split with none. I also say that, none, and then we can say here 3. And this is the maximum number of times it's going to do splits. How is it possible that stir split can take 0 arguments, or 1 argument, or 2 arguments? I'll give you one guess. Defaults. Help on stir.split. Look at that. We can set the separator, and we can set max split. Right there, we see defaults in the description of the function. And so tons and tons and tons of functions have defaults. Did you know print is a function? Help on print. And print actually has a ton of defaults. We're used to saying print value. I think I might have showed you end. I think I showed you file last time. We can say flush equals true. It'll automatically flush each time. And the whole point of a default is that, well, we don't want to, like most of the time, most people will just want to go with, well, the default value. But this gives us a lot of flexibility that we can mix and match things and set them accordingly. Okay. What I want you to do now is, and we're going to do like a thought exercise for 2 or 3 minutes to think about how you would want to do it, right? Because I don't think there's enough time to actually do it here. So I want you to think of an exercise, all right? And this function is going to be, let's say vowels in Word. So what I want you to do is, think about it at least, right? Write a function. Let's say all vowels, that takes a string as an argument. It returns a list of the vowels in that string. So if I were to say, example, if I were to say here, all vowels of hello, right, the return value would be E and O. Right? So I'll give you like 2 minutes to think about this, how this could work and what you want to do with it. And then we'll go over it together and we'll do more fun. We're going to put the fun in function, as people like to say. All right, no one says that, but fine. Okay, so let's look at this together and see what we can do with it. Well, I'm going to write my function, right? So I can say here def all vowels. And how many arguments are we going to take? One string as an argument. So I'm going to say here word. Oh, weird, word. What am I going to return? I'm going to return a list. So I'm going to start off, just as before I started with a total of 0, I'm going to start off, I'm going to call this output equals an empty list. And what I often do when I do this is I then go down a bit, I say return output. So now my function is going to start with defining this list. We're going to do something in the middle, and then we're going to return the output, return that list. Well, what are we going to do? I'm going to say for one letter in word. If one letter in AEIOU, then output append of one letter. And what this means is go through each letter in the word. If the letter happens to be a vowel, AEIOU, then add it to our list. And so now I can say here, all vowels of, I don't know, container. Look at that, pretty neat. Now, all by itself, fine. Like, the function is nice. But what we can do is we can then use it in a higher level structure. For example, watch this. I can say here, D equals empty dictionary. While true, I'm going to say here, word equals input, enter a word, strip. If word is an empty string, oops, then break. Otherwise, I'm going to say here, D of word equals all vowels of word. What is that going to do? It's going to populate our dictionary one word at a time, with the keys being the words and the values being the vowels from those words. We're going to have a dictionary in which the values are lists. But think of what we were able to do here. By using a function, we're able to go up a level of abstraction. We're able to just say, oh yeah, I'm going to put in the value from all vowels in word. What does all vowels do? Once it works, you can put it aside, treat it as a black box, and not think about the internals of how it's working. Think about it if you're driving a car, right? If you had to think about all the processes taking place in your car while driving, you'd never be able to drive. If you had to think about all the processes in a computer taking place while you're programming or doing anything, you would never be able to do that. And so by using a function, we're able to hide those details. That's abstraction. Hiding the details allows us to think bigger, higher, more sophisticated thoughts. The advantage in Python, of course, is that if something goes wrong with our function, then I can still go in, see how it works, and fix it. So I'm now going to do this. Let's do this. I can say here, test for the sake of testing. All right, encyclopedia, elephant, and octopus. Enter. And so now, well, it didn't do anything, but let's look at our dictionary. Look at that. Our dictionary now has keys and values. Now, do we have to do it this way? No, but this shows you the power of writing a function. Just go up and up and up and up and up. And so a really sophisticated, so let's say like a web browser that I'm looking at now with Jupyter, right? What is it? It's a ton of functions. One function calling the other. So when I click my mouse here inside of this text cell, what's happening is that some function is being activated. It's changing, it's then saying change the border to green. There's probably a function there saying set border color. It's also changing the focus, it's changing the way that the cursor looks. All these things are all functions. And so it's very common to write a function. You can do what's known as top-down programming. Write what you want to do in your function. So like, I could say here, def, I don't know, write, I don't know, let's say, calculate net worth, right? So I would say here it's like, bank balance equals, get bank balance. And then I could say here, house value equals get house value. And then I could say, I don't know what else I would have, pensions equals get pensions. And we can say here, return bank balance plus house value plus pensions. This is a totally okay function. What about these functions? Get bank balance, get house value, get pensions. Well, I don't know. They haven't been defined yet. I haven't defined them yet. This is what we sometimes jokingly know as, a small matter of programming. Oh yeah, you can just like go, that's all I need to do. By the way, just writing this sort of thing, get bank balance, it could be an hour of work and it could be a year of work, depending on your bank, depending on how easily they make the information available and so on and so forth. It's impossible to know. What we can do is use this abstraction, think what we want to do, attack the first, like get this first piece out of the way, and then say, okay, now I know these are the things I need to do in order to succeed. And little by little by little, you dig through all the things you need to do. Okay. Functions are like used everywhere. And in fact, you might have heard of like libraries, and we're going to talk about that in another 2 weeks. Talk about modules and libraries. Talk about libraries, software like APIs, SDKs, software development kits. It used to be a term that was commonly used. All these things are basically ways of saying functions that a vendor has provided to you, or that open source projects to provide to you to do all sorts of functionality. Meaning, if someone wants, like, so if like yesterday, in the whole coupon business, I was using a database called PostgreSQL. So I used functions that someone else had written to contact the database. Do I know what those functions are doing inside? No. But can I still call the functions? Yes. And by using those functions, I can think at a higher level, oh, I just want to check, is the coupon in there, not in there, unique, not unique, and so on and so forth. So writing functions is what programmers do a lot. I'll also say that if you choose your data structures well, your functions become much simpler, and that's a good thing. You want simple functions. You want someone to be able to look at it and say, oh, I see what's going on there. The moment that you have lots of if statements and lots of loops, lots of craziness in assignment, it's hard to know, like humans are just like not very good at keeping track of all that. So I think we're going to stop here for today. We've seen now how we can write some basic functions, how we can get input from the user, not via input. Right now, we're thinking at a different level. Yeah, at some point, the user has to have input, but we're calling a function with arguments, one or more arguments. The function is doing some processing inside, and then it's returning a value. And you can imagine all sorts of things, right? Here, I'll give you just one more example, right? So in Israel, we have VAT. I know many countries have VAT. The US has a rough equivalent called sales tax. Well, different countries have different things. So I can say here, like, def, calculate that. And I think it's now price. So I think that is now 70%. I really should know that, given that I'm a business owner, right? But like, yeah, I should know that. So anyway, what we can do is we can say here, return price times 0.17. Yeah, it is 17. Thank you. All right. So why is this useful? Why would I want to have this in a function? Well, obviously, if I want to calculate the price, right? So I can say here, price, and I can say then, price, let's say, price equals 100. So I can say here, calculate that on price, and I get 0.17. Fine. I can say def price including that for a price is going to be return price plus calculate that of price. And now I can say price including that of 100 is going to be that. That makes it easier to think about. Better yet, what if I don't actually have this hard-coded? What if the calculate VAT function goes to, I guess it would be the finance ministry, and retrieves it via the web each time so it can dynamically update it? I don't need to think about that. I can just think at my high level here of price including that and then call that function. This is the power of functions, and they really are, Seymour Papert like to say, a powerful idea. Once you get into your head how functions work and how they can be useful, really amazing, amazing stuff. So I am going to, so next week we're going to continue talking about functions. We're going to talk a bit about what more things we can do inside of functions. And we can also, we're also going to talk about local variables and global variables and the differences between them. And part of the beauty of functions is that they shield them from the rest of the world. You get like an insulated layer from everything. Oh, so by the way, I see a note here from Mal in Seattle. Oh, I don't know if this is supposed to be public, but like basically, they clicked on the form invite. So just send me email with your email address. If any of you are not in the forum and you want to be in the forum, I would love for you to be there. I know that a lot of times email from me and from my address like gets to spam folders, despite my best attempts not to have that happen. If you're not in the forum, email me your email address, and I will do what I can to get you into the forum. Absolutely, positively. Oh, Dory asks, does the order of defining count, or does it happen only when you call a function? Ooh, fantastic, fantastic. So the function itself is defined when we use def. So when I use def, I'm actually setting a variable. What I'm basically doing in def is doing two things. I'm creating a function, and I'm assigning that function to a variable. But the inside stuff, the body of the function, only runs when we call the function. It's like put in a deep freeze. So you can actually watch this. I'm going to say you're def, foo, blah, 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 blah. All right. This is not going to work. But Python says, okay, if that's the body of the function you want, fine. But when I run the function, Python says, wait a second, I have never heard of this before. So you can actually have a function body that will not work. By contrast, this is the really last thing. If I say def foo, blah, 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 space, blah, 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 Python won't allow me to define this function. Why? Because I have a space there and a space there. That's crazy talk. Who ever heard of a programming language in which which the language doesn't enforce indentation? So Python will enforce its basic syntax, colons, indentation, and so forth when you're defining a function, but it won't enforce names or calls or that sort of stuff, and it won't execute it for sure. All right, so I will put some homework assignments probably on Sunday in the forum. This video should be up within the next hour or so on the website along with the Jupyter Notebook. Next week, more with functions, local variables, global variables, more with defaults, fun, tricks, excitement, and so forth. I will see you next week. Have a fantastic, fantastic weekend, everyone. I really look forward to seeing you then. Enjoy, guys. There was another question. I didn't get a chance to do it. How simple should a simple function be? How can you tell your function is too complicated to be understood easily? Very simply put, this is a matter of great debate. And basically, there are many people who would say you should keep your functions so simple that they have no assignments and no changes to data. That's a whole school of thought known as functional programming. There are people who say that a function should have no more than like 10 lines. Also possible. Lots and lots and lots of arguments over this. The people who are increasingly determining this are the people who test software, who say keep it simple, because otherwise, like, boy, we got problems. All right, folks. I will answer more questions in the forum. See you next week. Have a great weekend. Bye, folks.